That was already a great discussion, and I think, time is short. We should try to move a lot of discussion into the afternoon, into the database session. And I was thinking while the posters are going on, I'll be sitting here as well if there are further questions or if you want to see anything in the data systems. I'm going to briefly demo. But it's an important subject that is very much discussed, not only within the science community, but within the funding agencies and so on, how to better share data. And, I'm really impressed with this Tephra database and hope that there will be some of the ideas picked up that Anthony already mentioned. And I'm going to run through these slides because I think the common discussion already went in the right way, that, we all want to use cyber infrastructure and so on, but we have a lot of challenges to address, and that's what Anthony already mentioned. This is from a different presentation I gave about a half year ago. Many of you might have heard about EarthCube, and some of you might have attended some of the workshops already that happened. I have compiled at some point sort of the main concerns in the science community, and they always come down to data discovery and access. Where is the data that I need? Where can I find it? How can I access it? Actually including samples there. And I'm going to talk a little bit about samples and how they can actually benefit from cyber infrastructure. There's the big issue of data quality. Can I trust the data? What am I actually working with? And then the whole issue of metadata and documentation, which also brings up concerns of, how much time do I have to actually document my data and give you everything that is necessary. But we need all of this. And, what we sort of in the cyber infrastructure world, we're talking a lot about reuse of data. And the reuse is only achievable if you make the data discoverable, accessible, they need to be safe, curated, and so on. But for me, the most important sentence in what Mark Parsons here wrote in his paper was data must be useful. And useful requires actually a bit more than just the data being accessible in some, catalog of data. You can add so much value, and that's exactly what Tephra Base has done in basically providing a synthesis of the data. Now, there is more to it, though. And, we talk a lot about the data life cycle now. And that also comes back to some of the concerns that were already raised. So you have data accessible in the Tephra Base, but is that long-term access? Is that going to be there in 5 years? What happens if Anthony gets hit by a truck tomorrow, which we hope is not going to happen, but you need to think about the long-term preservation. You also need to think about contributions. How will the people who contribute data to these databases benefit from it, get credit for it? Can the data be cited? Are there versions of the data? The data might change because you discover errors and so on. So there's a lot of curation necessary to make these databases useful in the long term. Increasingly, the funding agencies actually require you to share the data, as well as journals will in the future much more request the deposition of data that underlies the paper into repositories, into long-term repositories, and so on. How do we do that? How can that be structured into the process of planning your proposal and planning what you're going to do with the data, what tools are needed to help with the metadata management, and so on. So there are a lot of issues. And what it boils down to is that there are facilities out there that can help. And I'm a big advocate of what I call a disciplinary repository. So many of you might know IRIS. The seismological community has a big data management center in Seattle. UNAVCO has a big data center. They're quite a wide range of data centers or data facilities that support their specific communities. And I'm actually directing one of these for the National Science Foundation. It's called IEDA, Integrated Earth Data Applications, and I'm going to show you a few of the services that we provide. I think that these domain-specific repositories play a really important role because they are in direct communication with their user communities. They understand the data. IRIS is very focused on seismic data. They are experts in this. They will respond to the needs of the community. They can help people. But they, on the other hand, have the experts in data curation, the information technology experts, to make the data available to these web services, to a bigger infrastructure. They can make sure that the data is long-term preserved following international standards and so on. So there's a very important role of these repositories. And so, as I mentioned, this is IEDA. It's actually its sort of headquarters sits at the Le Mans d'Ordieu's Observatory where I work, but it is a collaboration with several other databases, and we are at the moment kind of restructuring the facility in a way that it can help other smaller databases to have that long-term sustainability and plug into bigger cyber infrastructures. So currently, our focus is on high-temperature geochemistry, low-temperature geochemistry, petrology, marine geology, geophysics, geochronology. We run various data systems there, but we've also, over the last 4 years since this facility exists, developed a number of sort of common data services. There's a sample registry that provides unique sample identifiers. We have visualization tools. Does anybody use GeoMap app? Okay, cool. We have tools for data management planning that a tool that generates data management plans for NSF, that generates data compliance reports and stuff like that. So it's a fairly broad range of services. But so within these data systems, I'm just going to ask: has anybody used EarthChem or PetDB? Okay, cool. Many others may be less known, like Geochron is just coming up. Okay, cool. Has anybody registered samples with CSAR? Excellent, yeah. But so anyway, going over that, I've mentioned that. So I wanted to just briefly explain the different type of data systems that we have and what their different functions are. Which is, in general, everywhere in the data world. These are sort of the three categories of data systems that are provided. So you have data libraries. Those are the easiest to get data in and get data out, but might not be the most useful. They are metadata catalogs, basically, that sit on top of a file system. So you search by whatever keywords are available, by author, by publication, and so on, and you get a sort of whole list of data sets back that are independent, but these systems usually have the ability to work with long-term preservation facilities, libraries, or be they sort of like the California Digital Library at that level, or your university library and so on, to ensure long-term preservation. The data libraries also make sure that data sets are uniquely identified. So for example, our IEDA repository registers every data set with a DOI, so it can be cited and so on. That's sort of the function of the data library. And then something like Tephra base is more of what we call a synthesis database. That's where you actually put the data and the metadata into one database. And so you can search within the data, and you can search and use the metadata to find that data, or even use the data themselves. As Anthony showed, you want to search for rocks that have between 50 and 55% silica. You're using the actual data to find what you're looking for. And then there are data portals, and that's, again, what Anthony referred to, is building networks of databases that can be queried from one single point of entry. And I'm going to show you, I think, oops, now it's not moving forward. I want to show you a few of those. I had put in issues about data publication, but I think I'm going to move that into the afternoon session to and give that a bit more attention. And I mentioned some of these, like, journal policies changing and so on, and citability of data. Where is that slide that I wanted? Here. So this is always a little bit of a risk if you do live demos, but I take that risk, and maybe that gives everybody also a bit more time to. So this is our homepage, but what I wanted to show you is an example of a data library. The data library would allow you to actually comply very easily with NSF data policies that they are starting to increasingly enforce, that you need to make your data openly accessible at the end of the grant period. So you have the ability to submit data here, to search and browse, and I just want to show you how these entries look. I'm going to go in and look for a specific author here who has submitted data sets. These are data set, geochemical data sets for mental xenoliths that we handle as well. So you can see the information about each of these, of the data sets, if the usual title and so on. Here is the download of the data file. It has some further information. Metadata such as method and so on is actually contained within the file. So we provide templates for people to use if they submit their geochemical data. So there's some guidance on, what to include if you have microprobe analyses or if you have mass spectrometry data and so on. And the important thing here, it also links to the publication. So when I click on the DOI, I'm actually going straight to the publication here. And it links back, as you see here in the corner, the Elsevier journals that we're working with link back to the data. So even on that page, you can directly go back into EarthChem and see all the data that is in that particular paper. The library, the EarthChem library, now also works quite closely with a number of new journals that have been established to just publish data. I don't know if you've heard about these journals already. Nature just released a journal called Scientific Data last year. There's another journal called the Geoscience Data Journal that's run by Wiley. There is AGU is now bringing out a new data journal. So these journals are focusing on publishing data sets with relevant information, explanations about the data, but not with the scientific interpretation. So this is a way for data that might be sitting on your computer and it's not, relevant enough for a big publication in EPSL and so on, to get it out and get credit for it. And these data journals all basically require the data to go into an openly accessible database. But then you can you can write more explanation about the data, and it is peer reviewed. So that's another aspect of these data journals. So we have one data set. I can briefly show that, how that looks. This was by Mike Carr. Oops. So there's a big explanation, the data files again, and here is the publication in the Geoscience Data Journal. So I leave it at that. If you're interested more in this, I can explain more. Two other things that I wanted to show briefly is we talked about portals. And this is something work in progress, actually. This website was put together within 1 week, so don't expect things to work really well. But I think, along the lines of what Anthony said, in trying to link databases and make them accessible in an easy way from a specific perspective, like the Tephra perspective, is really important. So this is an effort funded by the Sloan Foundation through the Deep Carbon Observatory to establish a data system for volcanic gas emissions, for the deep carbon degassing. And currently involved in this effort is IEDA and EarthChem, the Global Volcanism Program database at the Smithsonian, and the MAGA database in Italy. And so what we're doing is using web services, so you can I was going somewhere because I heard the talk yesterday about Mono Lake, sorry. Where? Okay, there we go. So this information that is shown here comes straight out of the Global Volcanism Program database. And when I click on details here, this is all sort of looks, as you might know, like the Global Volcanism Program database, and it's all information that comes straight from there. But it also pulls through a web service the geochemistry for that particular volcano or volcanic field out of EarthChem. And it will in the future, and that's not functional yet because MAGA still needs to build their web services, it will pull data for volcanic gas emissions from that same area out of their database. So this is just a concept that I'm showing you, and something to think about when we, might envision what can support Tephra research. It can happen in very similar ways. And the other. Okay. So this is actually, as you see, the data actually is from the USGS, but it's funneled through EarthChem because EarthChem operates a data portal for geochemistry. Now I have to get back here through way too many pages, which is the EarthChem portal. So at the EarthChem portal, you can search through a data set that now includes about 19 million geochemical data points. It's about, I think, well, let's go back because I think the portal page shows the current. Yeah, so it's 19 million chemical values for 843,000 samples. So there's a huge resource, and I would very much like to, integrate more of or link up with Tephra-based to also make that geochemical data available as part of this. So this is a federation of geochemical databases. NAVDAT is focused on North American volcanic data. PETDB is focused on mid-ocean ridge basalts and abyssal peridotiles, mantle xenoliths, and an increasing range of data that also includes low temperature, soil, geochemistry, and so on. GeoRock is a German database focused on ocean islands and so on. Then the USGS database is the National Geochemical Database, which is huge, and about 500,000 samples will be added pretty soon to this. A sediment database, the Metamorphic Petrology database of Frank Spear. So you see it's a network that you can actually take advantage of. So when you search here, what I did, and it's a bit risky, is look if we do have Tephra. And I actually saw there. So unfortunately, terminology being used in the literature to classify rocks is not that great. And we can see that when we actually search by names that people have used. If I use rhyolite here, I can show you a diagram that has samples between 40 and 80% silica. So there's a lot of bad data, but you can filter it out. Anyway, so when we go to Tephra, it's surprisingly only the PetDB database has Tephra data, and those are all, I think, or most of it is from ODP cores. But it could have clearly any other Tephra data could be linked into this. So what you can do here now is you continue to data selection, and you start basically identifying which type of chemical components you're interested in. All of these that are marked here are variables that are available for the Tephra data. So if, let's say, I'm clearing this, but I'm interested in the isotopes and rare earth elements, and I just cleared a lot of the other this. I can get the data integrated. If there are multiple papers for a single sample, the data gets integrated into one row. And then I go to the data, and here is my data table that has all the data as needed. So many samples don't have any isotopes available. They just have rare earth elements and so on. But you can then download it into as an Excel spreadsheet and work with it. An interesting aspect might also be as you do modeling, you do statistics. We have built interoperability with other databases, such as the Library of Experimental Phase Relations. So if you click on this, you actually go and search the Library of Experimental Phase Relations for experiments that have a similar composition to the rock that is listed here. If it exists, obviously it didn't. And it will, next year we're releasing the link to the MELS program, so you can immediately work with that as well. So I think I'm going to leave it at that for the databases and try to briefly go back to this. So I had just, because I wanted to talk a little bit about samples as well. Who is working with samples in this room? So, but I actually saw what surprised me, is something to talk about. It seems to be that Tephra base doesn't use sample names. It's sort of composition by Tephra, but not really linked to a sample. So I'm interested to see how that works. So samples actually have a big impact on how you build your data system. You need to provide information about the samples because that's required to properly evaluate if you don't know where the sample came from, how it was sampled, and all that kind of stuff. And you want to provide access to the sample, or people want it. They want to find out where is that sample because I might reanalyze it, I might reuse it. I want to see if that data is actually correct, and so on. So there are two main requirements when you want to work with samples on the internet, if you want to sort of have digital access to the samples. They need to be uniquely identifiable, and they need to have some sort of metadata that are cataloged in an online system. And one of the big problems that we have run into is that samples, unfortunately, have fairly random names that are completely ambiguous. So, oops. This is an example from the EarthChem database. Sample with the name M1 you can find all over the world. So if there is a paper that says sample M1 and another paper you see sample M1, they might not be the same. So no database can link that data together and say this is the trace elements for M1 and that's, the isotopes for M1. So this has been a big problem when we build the databases because we really want to link the data together by sample. The other thing is that samples get renamed or, the spelling of the name is slightly different. This is one and the same sample listed in 12 or so publications, and every publication has a slightly different name for it. And it's, in the marine world, you have a cruise, you have a dredge number, and so on, and you can sort of figure out which sample it is. But in the terrestrial world, it's crazy. So what we did, we started a sample registry and an effort to provide unique identifiers to samples. And these are, again, it's always my first message, they don't replace the names that you give your samples. They are social security numbers for the sample. They make them uniquely identifiable in data systems, in publications, and so on. That's the important point. And they come with a lot of metadata. They can. You're not required to provide all the metadata when you register a sample to get these numbers, but it is nice to have them because that way actually the whole record of that sample gets preserved as well. And if somebody reads a paper in 10 years, they can still find out all about that sample if there is an IGSN in the catalog here. The other thing is, I've heard from a lot of investigators who find in their drawers old samples that they say, like, oh, D15, where was this from? You have that IGSN on there, you go to the system, you know where that sample was from. You have your own sample management system, your own curational system. So these are sort of examples of the metadata that are there. What is important from maybe your perspective, because as far as I understand in the Tephra world, you have a lot of subsamples and small components that you analyze separately from entire layers and so on. This system keeps track of the genealogy of the links between samples and subsamples. So here is an example from ODP cores where you have the whole of the ODP drilling process as sort of the top-level parent, and then the cores, the children, and the core sections and samples become the grandchildren, and so on and so on, but you have the whole record there. The system accommodates other information like images that you want to upload and so on. The process is to register, to submit metadata, and there's a whole system, which is actually in the meantime an international organization that operates this IGSN. We have 14 members, international, Germany, Australia, France coming on, and so on. That makes this all work. And the journals are quite interested now to also use these IGSNs to link to the metadata records and ensure that that's available to their readers. So I encourage you to think about registering your samples. As I said, the other nice side to it is that we're actually building a catalog of samples that are available for research. So if you go and search and say, I want Tephra samples from that particular area, you might actually find it and be able to contact the owner of those samples and ask for a split if that's possible. There are a number of efforts going on that might be of relevance for you, particularly in EarthCube. We just got funded for a research coordination network on the Internet of Samples in the Earth Sciences that will work more on implementing these procedures and practices of unique identification, of citation of samples, documentation, and so on. Also building a registry of collections that are available at various institutions and so on. There is also a research coordination network on cyber infrastructure for fieldwork. Get involved with that. They just had a field course in Yosemite a week ago, I think, but there's going to be another field trip next year for that research coordination network. And there are a number of other efforts, and there's plenty of events happening if you're interested. Specifically, if any one of you is an editor of a journal, we have had this editors roundtable for a long time, but it just received funding from NSF that we can move forward in establishing best practices of data publication across all the earth science journals. So on October 2nd and 3rd, there's going to be a meeting at the AGU headquarters with representatives from all the major journals that publish earth science data, or earth science papers and data. So if you know some journals, let me know that I can check if they have been invited or not. Okay, that's it. I'm sorry for going on too long. And I needed to emphasize that I've just been in the field, because as a data scientist, you never get to go into the field. And I climbed that volcano.